Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. And today our topic will be LHRR, LHRR, WCCS. So what is the full form of these LHRR and LHRR, WCCS? So LHRR means linear homogeneous recurrence relation. That means these two or three topic will come inside recurrence relation, right? So LHRR linear homogeneous recurrence relation and LHRR WCCS means linear homogeneous recurrence relation with constant coefficient. So today I will discuss these two or three topics. Means DCRR I also will discuss if we have sufficient time then. And first one, recurrence relation. So in Fibonacci series, I told you recurrence relation. What is the recurrence relation? So first one, linear homogeneous recurrence relation. So linear homogeneous recurrence relation in is an equation that recursively defines a sequence A1, A2, A3, A4, and so on. That means all variable must have the same power. Linear means power should be 1, means all variable have the same power. And homogeneous reconciliation, that means there will be a right hand side also be given. So that means this is homogeneous. If right hand side is given, that means homogeneous. Oh, sorry, non-homogeneous reconciliation. And if right hand side not equal to is equal to 0, then homogeneous, right? So that means our series will be in form of first one sequence. So A1, A2, A3, A4, and so on. These are the terms of the sequence. A recurrence relation is written in the form an is equal to an minus 1 plus an minus 2 for n is greater or is equal to 2, and a naught is equal to 1, a1 is equal to 1 are given in our sequence, right? So this is called recurrence relation if our relation is in the form of, right? Now let an is equal to c1 an minus 1 plus c2 an minus 2 plus c3 an minus 3 plus and so on ck an minus k plus fn be a recurrence relation where c1 c2 and so on ck are the constant and last ck does not equal to 0 and fn is a function of n. So this equation, that means recurrence relation, always given of this type. An is equal to c1 an minus 1 plus c2 an minus 2. That means you have a sequence and you can write this sequence as in the form of this one. C1, C2, Ck your constant and Ck is your last term. Ck is your n minus k coefficient. So it will be does not equal to 0 and fn is a function of n, right? There is an example, and this type of example I have already discussed in our previous session. So let's see this example. This is very easy example. Find 2 marks question, actually this is. So find the first 5 terms for the following. Cn is equal to Cn minus 1 plus Cn minus 3, n is greater or is equal to 4. C1 is given, C2 is given, C3 is given, C3 is equal to 0 is given, right? So here n is greater or is equal to 4. That means our number will be started from n is equal to 4. So first 5 terms, so n is equal to 4, n is equal to 5, n is equal to 6, n is equal to 7, n is equal to 8. There are first 5 terms means 4, 5, 6, 7, 8. So just write the value. First one put 4, second one put 5, third one put 6, 7, 8. So as same as follow in our previous session question. Now linear homogeneous reconciliation with constant coefficient. So with this reconciliation we can define both of the relation. So linear homogeneous reconciliation with constant coefficient an is equal to c1 an minus 1 plus c2 an minus 2 plus and so on ck an minus k plus fn be a recurrence relation where c1 c2 ck are the constant and fn be a function of n, as we see above, same as it is. this is a linear recurrence relation and the order or degree is k. You can see here that term will decide the order or degree. That means ck does not equal to 0. That means your recurrence relation is of order 2. Right? We will discuss example of this relation. So ck does not equal to 0 and an depends on k. That means that an depends on the degree of the differential degree of the linear homogeneous recurrence relation. Right? Now this relation is called LRRWCCS, means linear homogeneous recurrence relation with constant coefficient, right? That relation, that means this equation one is not mentioned here, but you can see this equation is called linear recurrence relation with constant coefficient. Now, if in this equation your Fn is equal to 0, if in this equation series your Fn is 0, then you can say that this equation is called linear homogeneous recurrence relation with constant coefficient, right? If this term is 0, Fn is equal to 0, then we can say that the remaining equation is called linear homogeneous recurrence relation with constant coefficient, right? Now, if Fn does not equal to 0, then it is called linear non-homogeneous recurrence relation. So, if you learn this equation, if you just learn this series, actually this is a series. So if just learn this series and you can define your linear recurrence relation and also linear homogeneous recurrence relation with constant coefficient, right? Now there is an example here. An is equal to C1 An minus 1. So our last term is C1 here. So see, if C1 does not equal to 0, then we can define the order of the recurrence relation, right? So this C1 is does not equal to 0. That means 1 is the order of the this recurrence relation. So this recurrence relation is a first order linear homogeneous recurrence relation with constant coefficient, right? Constant coefficient, that means C1 is here and that C1 does not equal to 0. So we can say that the order of this recurrence relation is 1. Now second one, An is equal to C1 An minus 1 plus C2 An minus 2, right? So last term is your C2. So C2 does not equal to 0. Then we can say that this linear homogeneous recurrence relation is of second order. So we need to check our last coefficient, last constant coefficient. So our last constant coefficient is C2 is here. So order will be 2. C1 is here. Then order will be 1, C3, C4, Ck, and order will be K, right? Now, most important part is solution of linear homogeneous recurrence relation. So there will be asked a 8 marks question, sometimes 16 marks question can be asked in a final semester exam, and I will also share your old previous year old question papers also here. Then I will show you that there are 2 or 3 more questions in your exam, and now, solution of linear homogeneous recurrence relation with constant coefficient. So, first one, this is your series of linear homogeneous recurrence relation. So, write this series and this series of kth order, because AK does not, sorry, CK does not is equal to 0. There is CK here. So, CK does not equal to 0. So, order will be K. Now, when we will solve this recurrence relation, we will consider that this series have a solution. We have to consider the solution of this series, that we have a solution of this series, and the solution of this series is the type of An is equal to A alpha to the power n, right? We are just considering that this series have a solution, because we don't know, we have to find the solution. So we will consider the solution of this series, right? Now, we are considering the solution of the series is An is equal to A alpha to the power n, be a solution of the relation 1. This. Now, if the solution of the series is this one, then this solution will satisfy this series. So just write here the solution of the series. So An is A alpha to the power n, C1 a alpha to the power n minus 1 power is here. So n minus 1 plus c2 a alpha to the power n minus 2 plus and so on ck a alpha to the power n minus k. Right? Now a is the left hand side, a also in the right hand side in all the terms, to just take common and cancelled out. Now you can write it. Okay, so dividing by a alpha to the power n minus k. We are dividing this equation by a alpha to the power n minus k, and also here alpha is replacing by x coefficient, right? So you can take alpha also here. You can continue with alpha. There is no matter what is coefficient is here. So x to the power k. So n is replaced by n minus k. So n minus k plus this one, n minus 1 dividing. We are actually just dividing. So when we will divide this equation by this one, so n will be cancelled out. So you will get only k terms here. So you can write here alpha to the power k. You can also x to the power k is equal to c1 x to the power k minus 1 plus c2 x to the power k minus 2 plus and so on ck. So we are just finding our characteristic equation. So for the characteristic equation, you have to change your variable into a new variable, this one. So that equation is called your characteristic equation. Right? Now when you will solve this characteristic equation, it may can be, this equation can be quadratic equation, can be your order 3 equation, can be order 4 equation, right? So when you will solve this equation, then you will get roots, right? So if roots can be distinct, means can be different or can be same. So there are two rules when roots are distinct, right? So first rule, roots are distinct or different, right? So our solution will be an is equal to a1 s1 to the power n plus a2 s to the power n plus and so on ak s to the power n, where s1 s2 s3 are the roots of the equation and a1 a2 are the constant. Right? Now second one, we will better understand these two math rule by the example. Right? Second equation, when the roots are not distinct, suppose you have same roots, suppose you have 2 and 2, these are the same roots. So what will be method? An is equal to a1 plus n is getting 2 times, so 2a2 s1 to the power n plus a3 s3 to the power n plus and so on. So just we will see an example, then we will better understand how we will solve our recurrence relation. So this question, there is an example here. Solve the following recurrence relation subject to the given initial condition. So this question always ask 8 marks question. This is your 8 marks question and always ask in your final semester exam. So prepare this question, and there are 2-3 more questions. We will solve those questions by the same method. So just guys try to understand this question or solution of this question. So solve the following recurrence relation subject to the given initial condition. An is equal to 7an minus 1 minus 10an minus 2. N is greater or is equal to 2. A naught is given, A1 is given. Right? So these things always given in your exam. Always be given in your exam. So order of the given relation is 2. You can see here an minus 2. That means that coefficient will be your C2 and C2 does not equal to 0. Then we can say that our order is 2. Now next step, the characteristic equation of 1 is. So we need to write this equation in the new variable x, and we are considering that this series have a solution as x to an is equal to x to the power n. So our order is 2, so n is 2, right? So an you will write x square, because you are considering the solution of this recurrence relation as a is equal to x to the power n, right? Because you can see here we are considering here, we just considered that solution, this series have a solution an is equal to a alpha to the power n. So you will do same here, that we have a solution of this recurrence relation as an is equal to x to the power n, right? And n is 2 because order is 2. So x square, that term will be your x square is equal to an minus 1. That means power is 1 more less, so 2 minus 1. So a1, you will write as 7x minus, this is your constant coefficient, minus 10x to the power 0. So x to the power 0 value will be 1. So you have a characteristic equation as x square minus 7x plus 10 is equal to 0. So you will do same method, you will apply same method in our each questions. So you have a characteristic equation, so you, this is your quadratic equation. So now you can solve this equation. So you have 10, so divide 10, so 2 plus 5, that will be your 7. 2 into 5, 10. So x is equal to 2 and x is equal to 5. There are two roots and both roots are distinct, that means different. Now, the characteristic roots of 1 are 2 and 5. We can see distinct root. So, our distinct root relation is the solution of relation 1 is. So, what is the solution is of the relation 1 is a1 s1 to the power n. So, your solution an is equal to a s1 to the power n. So, s1 will be your 2. So, 2 to the power n plus second uh, constant b is here. You can consider a1 a2, you can consider a b c d e f g, whatever you are taking, that only constant, right? Doesn't matter. So a to the 2 to the power n plus b 5 to the power n is greater or is equal to 0. Now we need to calculate the value of a and b. So just calculate for the value of calculating the value of a and b, we will use these two conditions, right? So first one is given a naught is equal to 0. So just put n is equal to 0 here. So a naught is equal to 0, then you will get 0 is equal to a2 to the power 0 plus b5 to the power 0. And we know that if anyone have power 0, then that value will be 1. So a plus b is equal to 0. This is your first equation. Now second condition is given a1 is equal to 3. So put n is equal to 1 here. So 3 is equal to a1 is, that left hand side will be your a1. So a1 is equal to 3. So 3 is equal to a into 2 to the power 1 plus b into 5 to the power 1. So second equation will be 2a plus 5b is equal to 3. Now solve these two equations, then you will get a is equal to minus 1, b is equal to 1. Then put these values in our final solution. So your answer is an is equal to minus 1 2 to the power n plus 1 into 5 to the power n, right? So guys, this is the example. There is another one here. This example asked in your final semester exam. So solve the recurrence relation subject to the given initial conditions. So an is equal to 5an minus 1 plus minus 6an minus 2 for n is greater or equal to 2. With given initial conditions, a naught is 7, a1 is 15, right? So same process will be applicable. The order of the recurrence relation is 2. So order is 2. We can see here last term n minus 2. So order will be 2. So n is equal to 2 here. Now we are considering that series has a solution of the type of x to the power n. So n is 2. So x square is equal to 5x to the power n minus 1 minus 6x to the power n minus 2. So n is 2, just right here, 2 minus 1, 2 minus 2. So that will be 1. And we have our characteristic equation x square minus 5x plus 6 is equal to 0. So this equation is a quadratic equation. We can see here. So find the roots of this equation. So 3 to the 6. So we have x is equal to 2 and x is equal to 3 as roots of this equation. So both are distinct, right? So we can apply our distinct formula and so solution will be an is equal to a into 2 to the power n plus b into 3 to the power n is greater or equal to 0. So a naught is equal to a plus b. This is your first equation. and second one is for tan is equal to 1 because a1 is given. Just solve these two equations, then you will get a is equal to 6 and b is equal to 1. Write these values in our final solution of the in final solution. Then your required solution is an is equal to 6 to the power n plus 1 into 3 to the power n. So guys, prepare these questions because this is very important topic, and I am also sharing the important questions and important topic of your finals for the final exams. And these questions, uh, prepare these questions because these are very important questions. You can see there are total 12 questions here, and also more questions here, so there are total 11 here. So 12 plus 11 total 23. So guys, prepare these 23 questions because these all questions are coming back to back asked in your final semester exam. So prepare all these questions, right? And I have I think discussed all the topics of these all the topics related to these questions, because find the first five terms of the series sequence, this one. And here also you can see recurrence relation, LHRR define, and missing frequencies. And so guys, just prepare this question as a, and I also want to tell you the one thing that I will share two or three more examples related to GCD and LCM, because here I just saw a question that find the LCM and GCD of these two numbers, right, integers. So I will discuss in our next session this type of question. And here is your previous year old question papers, right? Wait a minute. Okay. Okay. Just give me a second. Okay. So this is your April 2018 question. So our topic here, solve the recurrence relation subject to the given initial condition. So guys, you will solve this equation, and using principle of mathematical induction, prove that this is divisible by 8. So you will solve both of the equation. And unit 4, that means two questions are here, so you will attempt only one of these. That means 8 question you can attempt, or 9 questions you can attempt, right? So this is your principle of mathematical induction question, this is the recurrence relation questions. And here find GCD of this one and express it into the form of this one. This question I have already told you, so just guys prepare these topics. And here decrypt the message, this one which is encrypted by the formula. This method I will discuss in our previous session. So I will just say that what topic you have already I have already discussed. Just prepare these topics, and you can see here this is a 2 marks question here. Define LHR or WCC, define and find the first four terms of this equation. So 2 marks, 2 marks, 4 marks is here. And also 16, 16, 32, to total 36 marks question, right? Just prepare your fourth unit. And there is another one question paper here. So this is your 2015 question paper. You can see 2015. 1 minute, it will take time. Yeah. Okay. So right. Now, this is your 2015 my question. Define measure of dispersion, list the method of measure of dispersion. So I have already discussed these questions, but here, unit fourth question, find the first five terms, define LHRR, what are its advantage. So guys, you can see that each and every year, 2 marks question are the same asked in your exam, right? There, 2018, find first four terms and define LHRR WCCs. In 15, define first five terms and define LHRR. These are the questions are very easy, so don't miss them. Here, using the principle of mathematical induction, also principle of mathematical induction is repeating. Recurrence relation, same method are repeating. So just solve these questions. And this type of question I told you, right? And I, if you guys have any doubt in this question, then I will repeat it again in our next videos, right? So prepare all these topic and all these questions, and in our next lesson I will just share 2 or 3 more examples. Otherwise, I will stop of these of your video session, right? And I just want to tell you one thing, and or that guys, give me your feedback also. If you have any doubt related to these videos, you can ask me. You are free to ask, anyone can ask me anything. So just ask me if you guys have any doubt, right? Thank you.